These are dark and mysterious and are widespread on the surface of Mars. No one truly knows what these are and how these are formed. These dark streaks are thought to be fine sand avalanches, exposing the dark material underneath. But many of these dark streaks look nothing like solid material in their appearances and distribution. Many of these dark streaks appear like liquid flows and need a radical shift in our understanding about the presence of water on Mars.
We have very similar dark streaks here on our own very planet. They have uncanny resemblance to the dark streaks on the surface of Mars, and in satellite imagery of Earth they can even look indistinguishable from the dark streaks on Mars in their appearance and pattern and in their dimension. Moreover, these dark streaks on Earth are found in seemingly sterile and lifeless terrain devoid of surface water. These are the vast mud volcano fields of the Hingol and Lasbela region in the Balochistan province of Pakistan. This region is riddled with a vast number of mud volcanoes and mud vents, constantly using thin mud that flows over several hundred meters, making their way around obstacles before drying out. The mud volcano region of Pakistan lies in close proximity to the subduction zone of Arabian and Eurasian plates. The underground water mixes and churns with fine clay and forces its way to the surface, possibly driven by the geological processes and pressure of underground gases, mostly methane. We have been exploring mud volcanic fields near and around Makran region, especially Hingol area and Lasbela and Avaran regions of the Balochistan province of Pakistan for the last 16 years. This is possibly one of the largest mud volcanic regions in the world, with the largest and most active mud volcanoes around. We have seen almost all sizes of mud volcanoes, from very small on the ground vents to the thousands of feet tall ones. These lie in one of the most inaccessible terrains. However, we reach them using our 4x4 vehicles and hiking gears. These mud volcanoes are present in very dry regions which receive very little rainfall throughout the year. Since mud flows from the mud volcanoes contain water mixed with fine sand and clay, we can see many water channels there. This water contains a lot of salts and minerals. There are mud flows hundreds of meters long, coming out from the vents of merely few inches wide. We have a very good idea of how these flows look like in the satellite imagery. Many of them were found using the satellite images on Google Earth. We followed them on the ground and found them to have very active mud flows. The mud volcano fields of Balochistan are seemingly lifeless plains. On our expedition of the previously unexplored mud volcanoes and their vast surrounding terrains formed from the mud flows seem devoid of any visible vegetation, both algae or bigger life forms. Part of the reason could be lack of precipitation in these locations, but also the chemical composition of the mud that has formed these terrains. We believe that if there is any life that exists in these mud vents and active mud flows contain mix of water, clay and chemicals, it could be extremophiles with partial or complete independence from the mainstream life in areas around these mud terrain.
Conventionally speaking, Mars is a dry, desolate and a dead world. There has been no evidence of liquid water on the surface at present times, except for the relics of its wet, ancient past, with flow channels, streams and lake beds that dried up hundreds of millions, perhaps billions of years ago. While there are vast amounts of ice under the surface in the form of permafrost, which is essentially frozen mud, and subsurface glaciers, several hundreds of meters to several kilometers thick, covering vast areas of Martian crust. It is not known if any known reserves of liquid water exist there. This dwindles any possibility of existence of life on Mars. The mud flows from mud volcanoes in Hingol and Las Bela regions have a very characteristic appearance in satellite imagery of Earth. They form dark streaks when fresh, containing liquid water and clay as they flow down the slopes of the mud volcanoes. Even on gentle slopes, they flow a considerable distance before getting thicker and drying out. While drying out, they gradually assume the color of the surrounding terrain.
These dark streaks are present in large fields in a specific area of Martian surface. They are several hundred meters long. Some are over a kilometer long. They very much resemble the mud volcanic flows on Earth as seen from the satellite images. Thus, it was very logical for us to say that these are potential mud flows. Not only that they resemble the terrestrial flows in terms of color and appearance, we found gullies, sinuosities, and levees in them. The physics around these gullies, sinuosities, and levees brought us to a logical conclusion that these are low viscosity fluid flows might have a lot of liquid water.
Mars has been geologically active in the past, and even now, there has been evidence of weak geological activity going on beneath the Martian crust. The fact that there are thick layers of permafrost and subsurface glaciers in the Martian crust over any possible geologically active spots makes us think that heat from such activity may result in melting of ice and churning of the resulting water with extremely fine Martian regolith to form a thin and fluid mud which may break out to the surface and flow down the slopes on Mars through a similar process that results in the formation of dark streaks in the mud volcano fields of Pakistan.
So far, we have gone through over 70,000 high-resolution images. At Mareekh Dynamics, our high-tech team is applying artificial intelligence and machine learning on these images to further understand them. Dark streaks on Mars, if found to be mud flows, will also prove the existence of liquid water very close to the surface, which may radically change our understanding of planet Mars and may help us find signatures of life there. The mud flows in Hingol and Las Bela region of Pakistan can be studied for the presence of life, likely to be extremophile microbes. The knowledge of their life cycle and processes and chemical signatures from their metabolism may help us calibrate instruments to the search for life at the sites of origin of the dark streaks on Mars itself.
Mareekh Dynamics aims to contribute toward ongoing efforts of making humans interplanetary by offering comprehensive engineering solutions for the fundamental problems in establishing permanent human settlement on Mars. Mareekh Dynamics seeks collaboration and offers to work together with global partners in making this dream a reality. We also offer our guidance and support to the astrobiologists who wish to do pioneer work in investigating the pristine mud volcano sites in Pakistan in order to investigate the analogy of these sites to possible mud volcanism on Mars. This could be pivotal in search for life on Mars. Mars is distant and desolate, but it holds the key for not only making humans and life in general interplanetary, but also for the exploration of outer solar system and beyond. Mars is the humanity's gateway to the stars.